Hi, welcome back to Missing Chemistry. We're going to talk about the electron configuration of gallium. All right, so gallium, the atomic symbol for gallium is Ga. It has an atomic number of 31 and an atomic mass number of 70. So now let's go ahead and do the pen. So we've got protons, electrons, and of course we have neutrons. Now, there are 31 protons because that number matches the atomic number. So all elements are electrically neutral, so we have 31 electrons. And to figure out the number of neutrons, all we have to do is go to the AMU minus the protons equals our neutrons, right? So we go 70 minus 31 equals 39. So we have 39 neutrons. All right, let's do our electron configuration. Now remember, when we do electron configuration, we start at the top here and we work our way down the slide like that. So let's go ahead and erase that real quickly. Okay, getting back to this. So now we're going to do the electron configuration, which we call the EC. So remember, we're going to keep on going until we run out of electrons. Remember that S holds 2 electrons, P holds 6 electrons, D holds 10 electrons, and F holds 14 electrons. Okay, so now let's go. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p1. So if you count that up, that's 10, 20, 30, 31 electrons. Okay, now let's do Hund's rule, orbital notation. So I'm going to do it right here where I have a little bit more space. I tell you what, let's go ahead and let's try to give ourselves a lot of space here. See if we can't do it in one go. All right, so now we're going to do our orbital notation. We'll set it way over here. All right, here we go. So 1s, up arrow, down arrow. There you go. 2s, up arrow, down arrow. Now, 2p6 has 6 electrons, so you need 2px, 2py, 2pz. So we go 1, 2, 3, 4, 5, 6. Okay, good so far. Now 3s, up 1, down 1. Same thing with 3p6. You've got 6 electrons there. So you go 3px, 3py, 3pz. So we go 1, 2, 3, 4, 5, 6. So far, so good. So we go to 4s, up 1, down 1. Now we're going to go to D. So we got 10 electrons right here. So we're going to need 5 suborbits. So we're going to go 3d x squared minus y squared, 3d xy, 3d yz, 3d xz, 3dz squared. Looks like we're running out of space anyway. So let's go ahead and do this. We go 1, 2, 3, 4, 5. They all have to be filled up first, according to Hund's rule. Then we start to down. 6, 7, 8, 9, and 10. All right, so last but not least, we have this 4p1. So we'll bring it down here. So we'll go 4px, 4py, 4pz. Hey, wait a minute. Do we really need all 3 of those blanks? The answer is yes, because electrons can jump suborbits when they become excited. So let's go ahead and put the up arrow in there, and that's that for orbital notation. Now, noble gas notation is a little bit simpler. It's NGN. It's probably one of the easier ones. And so let's find the nearest noble gas to gallium. Now, you can't use the one after because that electron configuration hasn't happened yet. So if you look on the periodic table, you'll notice that argon, Ar, is the nearest noble gas. to gallium. So, hey, guess what? Look at this. That is AR's electron configuration. Pretty cool, huh? So now you're going to go 3D10, 4S2, 4P1. Hey, that's different from this. Why did you write it differently? Because when you do orbital notation, you have to put the numbers in order. Okay, that's the rule. So just keep it simple there. It's okay to have different rules. That's fine. All right, and last but not least is our quantum number notation. QN, our quantum numbers. So now we have N, L, M, and S. And if you're not sure how this works, you should review my videos on quantum numbers, and I'll be more specific about where I'm getting these numbers from. But if you look at the N over here, that represents the energy level. So gallium is definitely in the 4th energy level. Not only is gallium in the 4th energy level, but it's in the P block. So the L value is going to be 1. The angular momentum value is 1. And since it's in the P block, it can go -1, 0, 1, -1, 0, 1. Well, gallium happens to be the first element, so that would be -1. And look at this arrow right here. This arrow is going up, right? So that means it's going to be positive. So we're going to say that that is going to be 1/2 positive because the arrow went up. And that is the unique set of quantum numbers for gallium. Well, that's it for this lesson at Moose in Chemistry. You guys be snarly, and we'll see you back here at Moose in Chemistry.